Okay, let's now take a look at the npm deform pieces. Oops. Okay, so first thing it needs is the output of this node, and then the npm sim, and voila, we have something that is being now retargeted, and it's being animated following the simulation that we had. So this is the simulation that we have, and now we can switch to this, and we have those fractured pieces following on this dynamics. Perfect. In terms of parameter, you have a start frame and an end frame. The reason that both are grayed out is because the first frame is coming from this here, from the npm solver, and the end frame has been defined here on this node, as you might remember. So you can override them if you want, but they are all flowing to this node automatically. After that, the most important thing to look at is this retargeting type. So if we get a little bit closer to this impact frame, we're currently doing point and piece. So it means that it's using two different algorithms to do the retargeting. So first one being used is this piece algorithm, which is just a basic transform. So each fractured pieces is looking at the closest npm point, and it's stealing the transformation matrix from this point and applying it to each piece. So as you can tell, when the material is just slightly deforming, it introduces a lot of cracks, which is not really something that we want. As opposed to this way of working, we have this other method, point base, which is going to not care about pieces at all. So each point of this geometry is just looking at the closest npm point, and yeah, these points are being transformed based on their closest npm particle. So obviously this introduces a lot of stretching. So to get the best of both worlds, so no cracks here and no stretching there, we are transferring from one method to the other based on how the pieces are being stretched. So here, if we go back to this first method, you have this stretch ratio, and this is basically telling you, so what is the amount of stretching where past that point, looking at this mode. So where I have too much stretching from that mode, at what point I'm going to switch back to this mode. And this is exactly what's happening. So this is the number that you're defining that will make you switch per piece from this mode to this mode. And in the end, when this is dialed properly, you get the best of both worlds, where you have like those very clean geometry here, those very like sharp pieces, but where it's just like deforming a little bit, you don't have those cracks that we have with this method. After that, we have these closed gaps. I'm not going to talk about that right now because I have a better example with metal tearing to show you this. And finally, you just have those attribute transfer, where if you want, like if you have extra data coming here that you want to transfer over this fractured geometry, this can be done right here. Okay, and the last thing I want to show you is that you're not forced to use this node. If you want to just like move pieces with an npm simulation, you don't have to go through this npm fracture node. So just as an example, I'm going to use a fuse here to decimate a little bit. Oops. To decimate a little bit the point cloud that we have on the first frame, and then copy 2 points, box. I'm gonna put some color so we can visualize that better. Random color per primitive, maybe a little more contrast. My God. Okay, like that. Good, and then I'm just going to frame old because we only have points on the first frame in this case. Now we can just, oh yeah, I need also to add this name attribute that I was talking about. So this is adding this name, it's going to be important. And now we can pass that to this node. So now it's complaining that we need this end frame because this is no longer being passed from this stream. So I can just go to manual mode, enable this, set that back to 50, and now we should be all good. And we are. So now if I play this, you can see that our points are now being transformed using the npm simulation. Looking very good. So this is definitely useful if you want to instance some geometry either on the npm points or like nearby. So you just have a distribution of pieces that you want to be captured with this npm sim and be deformed around. this is definitely like a good way of doing that. And yeah, in the end, it's just to show you that you're not always forced to fracture the original asset. You can just create new geometry and move it with this node.